Hello, this is Algebra C, page 2 notes for questions 12 through 17. For question 12, the easiest way to graph an exponential function is to create a table of values so you can get an idea of what it looks like. So I'm just going to do a quick XY table and then plug in a couple numbers. So I'm going to start with -1. If I plug -1 in for x, then I would have 3 times 2 to the -1. And remember from our last video, when we have a negative exponent, it moves that number to the denominator. So really that's 3 over 2, which is also the same thing as 1/2. So I'm going to plot a point at -1, 1/2. Or 1 and 1/2, sorry. I'm going to then plug in 0. To the power of 0 is 1, which just gives us the answer 3. I can also easily tell that by this number. It's our y-intercept. And then I'm going to plug in one more value. So that's 3 times 2 to the power of 1, or 6. So then I'm going to plot the point 1, 6. Generally speaking, exponential functions do a sweeping motion like this. So I'm going to go ahead and graph those points as I see them. And that would be the graph of that function. All right, for questions 13 and 14, you're asked to determine if the sequence is geometric. A geometric sequence will have a common ratio, meaning you're going to be multiplying each number by the same number. And we see -5 times -2 will give you 10. And then 10 times -2 will give you -20, etc. So our common ratio is -2. Question 14. 6 times what number is 30? Well, that's times 5. 30 times 5 is 150. 150 times 5 is 750. So your common ratio is 5. If you're struggling to actually see what the common ratio is, you can always divide one of the numbers by the previous, and you'll get the common ratio. But double check to make sure that that is the same ratio for each piece. Question 15 asks to simplify the expression and write the answer in scientific notation. As stated in one of the other videos, scientific notation is the only time you can have negative exponents. We use scientific notation as a way to note very large or very small numbers instead of having a lot of zeros either before or either after the number or in between the decimal point and the other numbers. Because sometimes we're talking about like millions of decimal places if something's very, very small. Or we could be talking about millions of zeros. So it's a lot easier to note using scientific notation than it would to be writing out these really long problems. So to solve this, we need to distribute the exponent 2.8 to the 4th power times 10 to the -5 times 4. 2.8 to the 4th power, I would use the calculator for this problem, is 61.4656. Then times 10 to -5 times 4 is -20. Now we're not done because scientific notation requires that only one digit be in front of the decimal point. So that means we need to take the decimal point and move it one space. So it's going to be 6.14656. However, if I ever have to move the decimal point, I have to change the exponent for the 10. So that way it's taking into account that space we moved. Since I took a larger number, and made a smaller number, I'm going to have to make this exponent a larger number. So negative 20, a larger number by one space, because I only moved it one space, would be negative 19. We're going to do the same thing for question 16. Distribute that power of 3, 3.4 to the power of 3 times 10 to the power of 5 times 3. 3.4 times 3.4 times 3.4 is 39.304 times 10 to the power of 15. Again, we're going to have to move this decimal place one spot. And since I had to take a larger number and make it smaller, I need to make my exponent one number larger. For question 17, we're adding polynomials. All we have to do to add polynomials is combine like terms. And when you're doing this, you're going to want to write them in descending order based on the exponents. So I see my highest exponent is 4x cubed. There's no other x cubes on here, so I can't combine it with anything, so I'm just going to write it down. 4x cubed. Then I'd move on to x squared. Here is 20x squared, but there's nothing else to compare it to because there's no other x squares, so I'm going to write plus 20x squared. The next would be minus 9x. I can add that to plus 50x because they both have x to the power 1. They can be combined. That would give me 41x. And last but not least, we have plus 30. It doesn't have any x, so it goes on the end. We cannot simplify this any further because there are no more like terms, so that would be your answer. That's all for this video. Check out the Algebra C page 3 notes for further help.